Is my screen visible to you? And
Yes, sir. Yes, sir. Yes, sir.
are the slides changing? Okay, I hope it is yes. So we'll start and let's hope people join in the meantime, in the middle. Okay. So good evening, everyone. My name is Shutanu Sadhu Khan. I am your facilitator of the weekly interaction sessions of NPTEL.
What do you will do?
Am I audible? Any problem? Okay. So welcome to the second interactive session of the Water Economics and Governance of the course code CE 86 offered through NPTEL by Dr. Manoj Kumar Tiwari of IIT Kharagpur. The course name is Water Economics and Governance. So this is August 8th and we are at the second week. So we actually we from NPTEL team and I personally also appreciate very much whoever has given feedback after the end of the previous session, and also people who have given reply or asked questions in the discussion forum. So that is also highly appreciated. And through this feedback only we are able to understand what is your doubt, what is the problem in understanding, and we can prepare further slides, or accordingly we can focus on clarification on those concepts or those areas where you are facing the problem. So in this session we will be basically solving majorly the problems, because in the last session, as it was very preliminary session, so we didn't discuss much problems in that. So it was very basic, but it was very interesting that people was expecting problems on that. So actually from now onwards it will be done like that way only, and the problems will help you in solving your assignment problems. But the thing is that as the doubts of the I mean, depending on the doubts, whoever has have asked, for example, Ajim has asked on uh, question number 13, 14 and 15 of the first assignment, but as the first assignment submission date is still not over, so we cannot directly solve those problems, because that will go against the uh, honor code of the course. But we will solve similar problems, and we will try to clarify your concept so that further you can solve those assignments. Okay, so let's start. Let me see how many people have joined until now. Okay, so 4 people have joined. Can you please provide the recording of the? Okay, yeah, definitely, Nipu. The thing is that in your NPTEL, let me clarify this thing first. So in your NPTEL, wherever you are accessing the code, accessing the course using your username password in the NPTEL website. So let me share that also. Uh, just wait. Mm. Uh, so here I have to share my entire screen. Okay. So I think my screen is visible. And now I will show you how you can access the, that is called your live sessions. So just wait. Yeah. So I believe the course, as you see in your portal, looks something like this. Okay. So here
Yes.
at the left bottom, you will see the problem solving session, July 2023. So you can click on it and click on this. Then you will see a problem solving session recording. So here you have to click here to view the problem solving session lecture. So here you have to click. In a separate tab, this Excel file will open. So there actually two links are provided here. One is the presentation folder link, and another one is the YouTube video link. So YouTube, if you click on the YouTube video link, so they are in a separate tab, a playlist will open. So in the playlist, we from NPTEL team will be uploading different weekly interactions, and through this presentation folder link, actually, if you click on the link, you will be getting the whatever the discussion materials, the slides, those will be uploaded in this folder. So if any one of you has problem in accessing this folder, so please email me at this email ID. I have actually in the last class I have told you that you can email me at, you can just connect me with social media, or you can just comment also in the discussion forum also that you are unable to access the material. So we from NPTEL side will try to provide you that. So my email ID actually, okay, I have not given here. So I have also posted in the discussion forum, and I will also post in the chat box. So you can directly email me if you are having any problem in accessing that material. So I believe here it is, the chat box. Okay. So I have in the chat box, I have posted my email ID. So you can email me directly, or you can directly connect with me in the social media also, or you can post in the discussion forum if you have trouble in accessing the folder. And also here is a discussion forum actually. So in your course window, at the left side there are week 0, week 1, week 2, week 3. There directly Professor Manoj Kumar Tiwari's lecture you will be able to access. So here is the problem solving session. Recording will be provided as I showed earlier, and above that the regular lectures, regular recorded lectures you will be able to access. Okay, so let's restart the session. Mm, okay, so I believe my screen is visible and slides are also changing. So first of all, we will solve a problem. In the previous class, Mr. Ojim asked a good question, that in the problems he had some troubles with the assignments. So we will solve similar problems, not exactly the same, and also we will solve MCQs, MSQs, etc. So here is the first problem for you. Assuming the current per capita water availability in India as 12 LLPD, that is lakhs or liter per day, calculate the same in 2018. That is, we are considering present as the 2023 year 2023. You have been asked the data for 5 years past. If annual population increase rate is 2% and water resource enhancements rate is 1%, how the water resource can be enhanced? As the population increases, the water demand also increases. So people look for new sources of water. For example, a desalination plant may come out at the coastal area, or maybe from maybe with the help of dams or something, or maybe some international treaties with other country. One country may take water from the other country. So there are various ways for increasing the water resource to meet the demand. So in this problem, it is a sample problem. We are seeing that the water enhancement rate per year actually, these are all increased rate is 2%. These are actually annual rate. This enhancement rate is also annual rate, it is 1%. So actually this in the first week lectures, this concept was not clarified. So I will not be asking you this problem to solve. I will just directly show you the solutions and the methodologies and the steps. So how to solve the problem? So to solve the you can solve the problem in many ways actually, but I am showing you one way. So if you have any doubt in understanding the problem, how it is going, or if you can suggest any alternative better method or something, you can unmute yourself and talk, or you can also ask for doubt in the chat box. Okay. So I have solved it in one way. So let us assume the population in 2018 was P0 and the available water was W0. Now, after 5 years in the year 2023, population will be P5. This is also we are assuming. Okay. So how the P5 will relate to P0? It is basic. The actually it is basically a simple you have in your school level you have done problems on simple interest or compound interest, like that way. So the population increase percentage actually simply follows the compound interest methodology. So in this way, year by year, the population of a current year is related with the previous year, and at the end of fifth year, it will the year will go to the power. So if it is 0th year, and it is after 1 year, it will be to the power 1. After 2 years, it will be P2 will be to the power this thing to the power 2, like that way. So at the end of fifth year, it will be the 0th year population, or 2018 population into 1 plus population growth rate to the power the number of years that has been passed from 2018 to 2023, that is year 5. Okay. So the population growth rate, as we expressed earlier, it is 2%. So we have done like this way: P0 into 1 plus 2 by 100 to the power 5. We have put the 2 by 100 in the place of population growth rate, equals to P0 into 1 into P0 into this will be your 1.02 to the power 5. Okay. So now again, similarly, let us assume the available water at 2023 or current situation, it will be W5. So how the W5 will relate to the W0? It will relate like this way. So W5 equals to W0 into 1 plus water resource enhancement rate to the power number of years passed, that is 5 here, equals to W0 into 1 plus 1 by 100 to the power 5, because the annual water resource enhancement rate, it is given as 1% of the previous year. So like this way. So if it is mentioned that it is a simple rate, then you can just you can do like that way, W into 5 into the rate divided by 100, like that way you can do. But if nothing is mentioned, by default you will assume everything as complex rate. So it will be W0 into 1.01 to the power 5. Okay, fair enough. Now, as per the question, the current per capita water availability in India is 12 LLPD. Current means at the year of 2023, and the water availability is 12 LLPD. So it is lakhs of liters per day. What is it actually? If total availability of water is W0 and population is P0, then per capita will be W0 by P0 at the year 2018. Similarly, at 2023, it will be water available at the year 2023 divided by at the population of 2023. So it will be W5 divided by P5. This is basically 12 LLPD. So just in the place of W5, we put this relation. W5 equals to W0 into 1.01 to the power 5. And just in the place of P5, we put this equation. P5 equals to P0 into 1.02 to the power 5 that we have derived earlier. So W by P5, W5 divided by P5 will come like this way. W0 into that term into divided by P0 into this term. So equals to, we can simplify like that way, W0 divided by P0 into 1.01 divided by 1.02 to the power 5. By further simplification, we get the per capita water availability in the 2018 year as W0 divided by P0. That is nothing but this divided by this. This divided by this term we take, and the rest of the term comes at the left hand side. So this actually come out to be 0.952 if you calculate it, and the answer will be this. So hope it is clear. Let's see if people have got any question. So okay, so I think it is clear to everyone. And you will be able to through this problem, if you understand, you will be, I believe that the assignment doubts as you are having, you will be able to solve those questions. But if you understand the concept, if you just remember the problem, you will not be able to solve, because the data are changed. It is similar, not the exactly same problem, but if you understand the concept, I believe solving assignment problems will not be a problem. So from where you taught the problems? Actually, the problems are Nipun. The problems are similar with whatever given in the assignment. Actually, in the last class, people told me that they have been they are having doubt in some problems. So I have prepared these problems in line with the problems you are having doubts. So number 15, 14 and 13, these three problems, actually people have told that they are having doubts. So I am solving similar problems, because same problem I am not supposed to solve, because the assignment submission date is still not over. So if I solve the same problem, it will go against the code. Okay, honor code, the course. Okay, so let's continue. Uh, Now, okay. So I think it is clear to everyone. So we'll go to the next problem. So it is basically a MCQ or multiple choice question. The question is, over the next 10 to 20 years, which of the following sectors in India is likely to see the least growth in water demand? Option 1 is industrial sector. Option B is energy sector. Option C is agricultural sector, and option D is all of them. So you can type your answer in the chat box, and also you can okay, Nipu is telling A. Jobin, I believe your uh, speaker got okay. I can also. Ah, okay, so okay. Anyone else? Nipu has told A. Have I stopped presenting? Just do it. Yeah. I think the presentation has been stopped. So from current slide. Hmm. So, yes. Now it is there. So the four options are industrial sector, energy sector, agricultural sector, and all of the above. Okay. So Nipun has given answer A, and Danesh is also telling A. Okay. Okay, we will see what is the answer now. So the answer is basically the agricultural sector. The question is, you are expecting to see the least growth. Uh, some people may think that it will may confuse it with no growth at all, but it is not so. Growth will occur in every sectors, industrial sector, energy sector, and the also in the agricultural sector. But if we compare the growths, then what will happen, that we will see that agriculture is there in the country for many years. I mean, the industrial, and because India is a developing country, so industrial sector and energy sector, these are booming. So the growth in these sectors will be more than the agricultural sector, but growth will be there in all the sectors because population is expanding and the demand for food, industrial product, and energy, all three are increasing. Okay, so I think you have got the answer. C, agricultural sector will be correct answer. Okay, so let's go to the next section. Some people of you, I believe, are BTech students. They are preparing for GATE exams, and for I believe the last 4 or 5 years, GATE people are asking multiple select questions. MCQs are where the choice are multiple, but answer is one. But MSQs, the option may or may not be multiple, the correct options. So let's have such a question. The daily per capita consumption of water apparently increases with option 1 is higher life standards of people, option 2 is availability of sewerage in the city, option 3 is metered water supply, option 4 is wholesome and potable quality of water. So all of them may be correct answers, none of them may be correct answers, one of them may be correct answer, or more than one of them maybe correct answers. There are all the four possibilities there. So let's see what people are answering. You can type your response in the chat box. If you have doubt, you can unmute yourself or ask questions, or you can also uh, type your doubt in the chat box. Okay, Danesh Anbu has given answer as 1, 2, and 4. Okay, you can read the question. I believe this is if you just apply your common sense, you'll be able to answer this question. So not a big deal. Okay, I believe I am audible, right? Yeah. So we'll not wait much for this question. Uh, so whatever Danesh has answered is correct. So higher life standards of people, availability of sewerage in the city, and wholesome and potable quality of water. These are the three correct answers. Metered water supply, size of the city also directly affects the daily per capita consumption. But in case of metered water supply, if you are metering whatever water is being supplied to the household, then actually people becomes cautious in their water usage. That uh, doesn't uh, have a positive contribution towards the per capita consumption. Basically, metered water supply, in case of if the water supply are metered, then the water will apparently either decrease or remain unchanged. It will not increase basically. So whatever Ganesh has answered, that is correct. So option are 1, 2, and 4. Okay. So let's have another MCQ. Which of the following statement is false? Option A, agri-based industries such as textiles, sugar and fertilizer are among the top producers of wastewater. Option B, the population density supported by India's river basins is lower than most other developing countries. Okay. Option C, India has a reasonable water footprints among the top rice and wheat producing countries. And option D is steel plants and thermal power plants are the major contributors to annual industrial wastewater discharge. So it is an MCQ. One of the statements are false. You have to identify which one. Okay, you can type your answer in the chat box. Because I see that most of your will solve numerical problems in due course of time, but as I see, it is most of your problems are MCQ type problems in the assignments. So I also selected mostly MCQ problems, but if you are having doubts in numerical problems or having doubt in any type of concept clearing, then you feel free to ask questions. And also you can ask in the discussion forums, me or any other team member from our NPTEL side will try to answer or address your queries. Okay, so I believe I will suggest people to have not much people have joined. Okay, so I will request everyone. Okay, okay. So I will request everyone to keep actually your pen and notebooks with you so that the numerical problems or maybe the options in a very short, just a informative position. For example, agree the population density uh, uh, in the rice and wheat and steel and thermal power plants. Like that way, you can just hint wise you can write those options, and later when you can think like that way. And also numerical problems, it will be beneficial for solving numerical problems also. So I request everyone to please take a notebook and pen whenever you are attending the sessions. Okay, it is also for the people who have not joined, because it is being recorded and uploaded. So people will later, those who are not able to join, they will be able to grasp. Okay, yeah, okay. Thank you, Danesh. Okay, so while people think through the problem, let us clarify some doubt which uh, people had in the last session when we were conducting. So people asked me, actually people wanted to go into a bit deeper into the cloud seeding. What are the chemicals? What are the types, like that way? So one people has given the answer correctly, that one of the chemicals which is very popular chemical, that is silver iodide. But there are also other types of chemicals, and cloud seeding can be done in a variety of ways. The most method is obviously by chemicals or salts. So uh, as I told, that there are within chemical seeding also there can be two types. So I actually couldn't remember the names. So one is heat based method, and one is basically as a size based method, where the particles eventually becomes a larger droplets and becomes heavy and they fall. So that is basically called as static seeding. And the latent heat based method, where actually the latent heat released by freezing is exploited, and the precipitation or raining occurs. This method is called the dynamic seeding. The chemical that is used in case of dynamic seeding is basically hydroscopic materials, just like table salts, etc. Research is actually currently going on that, but the static seeding method is a conventional method where silver iodide, potassium iodide, uh, dry ice, or that is called as solid carbon dioxide, or liquid propane that expands into gas after release. So these type of conventional chemicals are used in case of chemical or salt based method. So there are also other type of cloud seeding methods. As you can see that in case of static seeding, upon sufficient growth, liquid droplets become heavy enough to fall as precipitation from the clouds, because it actually coalesces small droplets and it becomes larger ones, and it rains. So the other type of cloud seeding methods are by electric charges. So United Arab Emirates, the video we saw in the last class, that was actually not a very new one. From 2021, the Gulf country, like the United Emirates, is using the electric charge method. Drones equipped with payloads of electric charge emission instruments and customized sensors are used in this technology. Those drones fly at low altitudes, and with the help of that electric charge emission instruments, those drones deliver electric charge to air molecules, inducing precipitation. So the chemicals and salts method is one is by the electric charge method. Another one is there, that uses the infrared laser pulses or IR laser pulses. So this is an electronic laser assisted water condensation mechanism direct to the air above any city. So the method was first tested in Berlin in the year of 2010 by the researchers from University of Geneva. In this process, laser pulses encourage atmospheric gases such as sulfur dioxide, nitrogen dioxide, which are present in traces of amounts in the atmosphere above uh, industrial cities, and it helps to form particles, and those particles acts as seeds for the precipitations. So these are basically three methods by which cloud seeding can occur. And also, apart from AGI, in case of chemical or salt based methods, carbon dioxide, propane, potassium iodide, etc. can be used for seeding the cloud. Okay, so let's come back to the previous question which we had. So option B is the correct answer. Uh, the explanation is the population density supported by India's river basin is higher than most other developing countries. It is not lower because actually India is very old civilization and river based civilization, and also agricultural based civilization. So the river density, the population is forming or accumulating at the river basins of India from a long time. So it is not less than the other countries, and the rest are all other statements are basically correct. Okay, so let's continue. So I believe you people have seen this picture in many places. So the shorter wavelength coming from the sun, and after getting reflected from the earth's surface, the wavelengths are becoming longer, and these longer wavelengths are trapped with the help of different gases those are present in the atmosphere, such as carbon dioxide, methane, nitrous oxide, etc. So this phenomenon is called greenhouse effect because in the polar regions or in the cold countries like Russia, Canada, etc., there they use a glass room to maintain temperature which are suitable for cultivation. So those glass rooms are called greenhouse. So similar phenomena is occurring at our atmosphere. So actually this is called a greenhouse effect. If the quantity of these greenhouse gases which are there in the atmosphere are more than the required level for the sustenance of life on earth, then what we get is called as the excess greenhouse effect that causes the global warming. So we have seen this picture, I believe, many in many places. This picture, I think, many people have seen also. So this is basically a imagination of a catastrophic future where the sea level gets rise, and different uh, that is called the buildings which are there in the coastal areas, those go under the sea. So in this position I would like to ask too tough. Okay, Nipu is saying, but I think this type of MCQs you will be getting in your assignments problems. However, most of the MCQ also you can Google and find out the answer. But the idea is to understand the concept behind that thing, that why something is the way they are. This is the idea. This is the main reason. So if you are having any doubt in understanding any concept, you can ask questions. feel free to unmute yourself, ask directly, or you may type in the chat box or in the discussion forum. Okay, so at this point I would like to emphasis on one thing, that global warming and the sea level rising, those two threats. Do you believe that these two things are connected together? So if yes, type Y. If no, type N. Whatever you feel. Just everybody. It is not a. I mean, it's not something serious. You can type. Okay. Okay. Yes. Okay. So we have also seen this picture, right? That in polar regions there are ice caps. So those ice cap gets melted, right? And the water, those are deposited in the form of ice and are floating in the water. Those come into the liquid phase, that is in the water phase. From the solid phase it comes to the water phase. This is called the melting of polar ice cap. So how many of you believe that global warming and polar ice cap melting are related? So let's see, type Y for yes, N for no. Or so global warming causes. Okay, so Danesh is answering. What I mean, are there other people are in the meeting, right? Okay. Okay, so the thing is that global warming is causing the melting of polar ice caps, and global warming is causing the sea level rise, both. Now, directly or indirectly, it is the question. So here my question too is, melting of polar ice cap is causing the sea level rise or not? Actually, we will link it to something that is related with economics and governance. That's why actually I came into asking you this question. So how many of people feel yes to this, and how many of you people feel no to this? Type Y for yes and N for no. Okay, so Danesh Anvu is telling yes. I think that when I also came to this topic, I also felt like that way, that it is definitely because of the melting of the ice cap only that ice is coming into the water and the sea level is rising. Simple fact. Uh, what is the problem in it? So I also thought like that way, but the things are not like that way. It is pretty different. We will now see. So let's watch a YouTube video together.
Say you have
I think it will not be visible. I have to again reshare my screen. Okay. So it is a problem with Google Meet. Zoom is better in this aspect. Asked to conduct the sessions in this only. Okay, I believe my browser is okay, visible to you. So is the video is visible to you? I believe it is yes. If it is no, please unmute yourself and tell. Okay, sound and or link is provided. You can yourself also watch. No issues with that.
have a container of water holding an iceberg. A piece of the ice above the water level suddenly breaks off. Then it goes underwater and melts completely. My question to you is, will the water level change? Take a moment to pause the video and see if you can rationalize the answer yourself. Let's start from the beginning. Here's what the container looks like before the iceberg was added. Notice the water level is lower than before. Now here's the same container with the iceberg added. As you would expect, Water rises whenever anything floats on it. In the case of the iceberg, it will displace its own weight of equivalent water. Now, if a chunk of ice breaks off and melts into the water, it will add to the water's volume, making it rise. But at the same time, there's less ice floating than before. Less ice means less weight pushing against the water. Because both situations balance each other out, the water level will not change. If you have a different interpretation, feel free to leave it in the comment section below. As always, thank you for watching, and don't forget to support us with a thumbs up.
Okay, I believe everyone has watched that video and nobody had any problem with the sounds or so. So I'll again reshare my screen. Okay, the link is provided so that later people can also watch it. The thing we saw in the video is something like this. So the ice which are floating on the water, mainly in the polar regions, those if get melted by Archimedes principle, we know that it will not displace excess water. So the water level is not supposed to change much. Though some people may argue that it is salty water, it is ice is made of fresh water, there are no salt is there, but still no significant rise in the sea level. Just it is called 1.5. The IPCC, which is the Intergovernmental Panel on Climate Change, so whatever they have estimated, so that significant rise in water level will not occur because of the melting of the polar ice caps. So this is basically wrong. Okay. Now, what causes the sea level rise then? There is a question mark. So the main contributor is definitely the melting of ice, but not the polar ice which are floating on the water. Those are basically the ice of the glaciers. So this is the portion where we ended our last lecture. So this is the water cycle, and the sea level rise occurs because of the disruption of the water cycle. So we can see that there is a rate with which the glaciers water is getting melted and is converted into river water, and that is a rate with which the river is flowing into the ocean. There is a rate with which the ocean or water from the water bodies is either transpired with the help of the vegetation or are evaporated. Those are together called evapotranspiration. There is a rate of the evapotranspiration, and there is a rate with which those are again going back to the glaciers and getting deposited in the form of ice on the top of the glacier. So what happens with global warming? Global warming increases, disrupts the water cycles. That is the rates are constant. It is in steady state. But in case of global warming, the rate of the melting and flowing river water into the ocean becomes more than the rate of the deposition of ice, the evapotranspiration and the deposition of ice on the glacier. So the deposition rate actually becomes lesser than the rate of melting. So in this way, the deposition of water occurs in the sea, and it is the level rises. That some places sometimes the ice is on the land in cold countries. So those land ices will contribute to the sea level rise, but not the polar ice caps which are already floating on the water. Those what ice actually melting will not much contribute significantly. It will not contribute to the sea level rise, but this will contribute. So the water cycle disruption. So now, what is our point of focus here? So our point of focus is if you have also seen the lecture, so we'll solve problems based on that. So this is the water body. So either this is this water body or this water body. This sometimes in a closed area the water is just like lakes, so those are called watersheds. So in chemical engineering we call it as a control volume. So in that control volume or watershed, water is coming in and going out by various means. Sometimes water through the pores of the soil goes from one water shed to the another water reservoir also. So in terms of the watershed, from where the water is percolating out, that is called outfiltration, and the other shed where the water is coming in, this is called the infiltration in terms of the other shed. And balance equations can be established based on one watershed or control volume. So these are called the water balance equations. So now my question is to you is that the water budget equation or water balance equation is based upon which principle? So the principle A is law of conservation of energy, B is law of conservation of momentum, C is law of conservation of heat, and D is law of conservation of mass. So you can type your answer in the chat box. Option D. Okay. So what happened to other people? You can Danesh is very actively answering, but other are not. Okay. So okay. So we'll see the answer. And we'll come back to with the answer actually, and we will see the water balance equation in detail. So what are the different components of the water flow through a water body, and how to utilize this equation for solving different numerical problems. Those are relevant to your assignments as well as your exam. So we will come into that, and we will also clarify if any doubts you are having. So now we'll take a 5 to 6 minute break, and we will continue after that. We'll join in the same link if you are leaving, and if you are not leaving, then here only we will restart after taking a 5 or 6 minute breaks. So we will start at 7:05 sharp. At 7:05 p.m. we will restart the session. Okay. So so this is an interactive session. If you want, if you I'll pause the recording after some time. So if you feel that you are you want to contribute something, you want to say something, any comments, or if you are not understanding something, I am going fast, then you can unmute yourself or tell that if you are having any problem. Okay, so I'll restart the recording. Hope my screen is visible and I am live and clear. Okay. So the answer which Donish gave, that is true. It is basically law of conservation of mass. Now we'll see the balance of the water flow through a water body. This is a control volume equation basically, which is based on the conservation of mass, P plus Q in equals to ET plus delta S plus Q out, where this P term represents the precipitation or raining. This is a summation of evaporation plus runoff. Runoff basically it is the overflow for a disconnected water body. Why it is disconnected? Because here the normal infiltration or outfiltration are not occurring, or the water body is basically full. So the level is not changing. So whatever the precipitation coming into the picture, that is going out either through evapotranspiration or by overflow. If it is not the case, it is open from all aspects, then the left hand side term Q in and the two terms right hand side, that is delta T and Q out, will be there. So Q in is water flow into the watershed, ET is the evapotranspiration, that is transpiration occurred by either the that is phytoplankton or the other vegetations, or maybe water hyacinths or whatever vegetation that is connected to the water body, and evaporation, that is direct evaporation, direct phase change from the liquid into the vapor phase of water. Delta S is the change in the water storage. It is basically the volumetric change. If the precipitation is given in millimeter terms, then we have to multiply it with the surface area of the water body to make the equation in make the entire equation in volumetric term, because delta S is in volumetric term. If delta S is given in terms of heights or change in height of the water body, then you have to multiply it with the surface area of the watershed to make it in volumetric terms with the equation. Now Q out is the water going out, so water flow out of the watershed. Okay, so I hope the equation is well understood, because many problems we will solve on the basis of this equation. So let's see whether there is an inquiry in the chat box. Okay, so okay, so if you have problem in understanding the equation, you can unmute yourself and talk, or you can post, because this is very important equation in terms of basically it is nothing but the mass balance equation. Even if you have not studied the equation, you can solve the problem, but the thing is that you have to then think, more time is required then to solve the problem. Okay, so we'll continue. So as I told, why is this a law of conservation of mass? Because this is nothing but the mass inflow minus mass outflow equals to change in storage. Here in inflow, all the water in terms is considered. Here in the outflow, all the water outflow out terms is considered, and it is basically a hydrologic balance. Okay, so now we'll solve a problem. The percentage of precipitation converting to runoff of a 400 hectares subcatchment is 32%. If the subcatchment receives annual rainfall of 1700 millimeter, note the unit, the average daily runoff generated to the nearest integer you have to calculate. So here the annual rainfall is given in millimeter unit. The runoff is provided as a percentage of precipitation, and it is 32%, and the surface area of the catchment is provided. Why? Because you can understand that the rainfall is in millimeter terms, you have to convert it into a volumetric term. So here are the options. 5962 cubic meter, option B 6000 cubic meter, option C 5883 kilometer, sorry, cubic meter, and option D is 6101 cubic meter. So I'll wait for 2 minutes for you to solve the problem. And here is one hint. 1 hectare equals to 10,000 square meter. This you can use. I believe it is 1,000 or 10,000. I think. Also forgot. Okay, let me check. You can Google it. Yeah, 10,000 is correct. Correctly provided. So I'll wait for 2 minutes for you to solve the problem. Very few people have joined today. Okay. Okay. Danish is saying option A. Any other? Actually, maybe your attendance, I don't know whether it will be taking for marking or not, but see, these problems just for learning, even if you are giving the wrong answer, no issues with that, because it will not be marked. So don't be shy away, and don't get shy away from calculating the answer. You can calculate, and even if you are coming with the wrong answer, no issues with that, because this note would be graded. Only the assignment, these are for practice sessions and for interaction, for doubt clarifications only. Whatever things you will be getting, you will be doing in your assignments and exams, only those will be graded. So don't be afraid if your answer is wrong or something. You can calculate. So Jobin and Nipu can answer. No other has joined, I think. Okay. Later people can also practice. Okay, so 2 minutes over. I'll be going through the solution methodology. Mostly Danesh has answered it correct, I think. As far as I remember, option will be A, I think. Okay. So we'll see. Uh, so this solution. So the data given, those are the area, that is 400 hectares. So 400 into 10,000, that is 4 into 10 to the power 6 square meter. Runoff as a percentage of precipitation is given as 32%. Precipitation is that is the P term in the equation of water budget equation, that is 1700 millimeter, and the runoff as percentage of precipitation, you can express it as annual runoff divided by precipitation into 100. So runoff as a percentage of precipitation is expressed as 32%. So annual runoff divided by precipitation, you can express it as 32 by 100, like that way. Sorry, yes. So as a percentage of precipitation, it can be expressed. So as it is given 32%, so it is 32 by 100. This equals to the annual runoff divided by the precipitation. Now the precipitation is given as 1700, so we put that value here. So this 170 comes this side, and annual runoffs comes into 1700 into 0.32 equals to 544. Remember the unit, it is millimeter. So average daily runoff equals to annual runoff into surface area of the catchment divided by 365. Now here we are converting the unit from millimeter to the volumetric unit by multiplying it with the catchment area. So here you can see the utilization of the area of the catchment. Then the average daily runoff equals to 544 that we calculated the earlier, the annual runoff. Put that value here, divided by 1000, because here it is in millimeters, so we are converting it to meters, because the answer is in cubic meter, into the area, that is 4 into 10 to the power 6 square meter, divided by 365 days per year. So as this is annual runoff, so daily runoff we are calculating with the help of dividing it with 365, and the answer comes out to be 5962. So I believe it is option A. Yes, yes. So Danesh has given the correct answer. Okay. So we will move on to the next problem, that is MCQ. The question is as follows. A country with per capita water availability as 800 meter cube per year will be considered as, option A is water surplus country, option B is water stressed country, option C is water scarce country, and option D is country with adequate water resources. So you can type your answer in the chat box, or you can unmute yourself and talk. Okay. So I believe Nipu has given answer C. Again, you change it to B, right? For this problem, I believe. Oh, no, no, no. Okay, okay, okay. For this problem, we have given option B. Danesh is telling, Lawrence has told that is option C, and Jobin is telling it is B. Okay. Okay, so as no other problem is there, we will move on to the solution. So as per international norms for global water distribution, for water scarce country, the per capita availability will be less than 10 LLPA, that is lakhs of liters per annum. For water stressed country, it will be in between 10 and 70, the per capita availability in LLPA unit. And for water adequate country, the per capita availability in lakhs of liters per annum will be more than 70. So majorly all the countries are divided in these three categories. If you have seen SAR's lectures, then there is a good map which shows different countries of the world which fall under what scarce, either stress or adequate, which under which category those countries fall. Those are very well uh, actually color coded in the lecture by Dr. Manoj Kumar Tiwari. So if you have watched that lecture, then actually it is a pretty good categorization of the different countries of the world which fall under these different categories. Okay, so if some countries are very extremely water scarce country, and some country are water surplus country, so those water surplus countries come above the water adequate countries, so they are, the per capita availability is much more than the 17, and maybe more than 20 LLPA. And in the countries which are very much uh, water scarce, the extremely water scarce country, those are those comes under 7 or 5, like that, under 6. So if it is in that range, 5, 6 or 7, or even lower than that, those are extremely scarce country. And if it is more than 20 or 21, so those countries are highly water, but though not much countries are like that. For example, Brazil is, I guess, it is water surplus country, but not much countries come under those extreme categories. Majorly, countries are divided within the three categories only. So some country of Africa, where which is near to uh, the that is the desert, so those country may come at the highly water scarce country, but majorly these countries are categorized under these three categories. So we have so actually that there the unit is LLPA. LLPA means lakhs of liters per annum, and here it is the unit meter cube per hour, meter cube per year. So it is basically 8 LLPA. So you can see that 8 LLPA comes in the below 10. So it is, as it is water scarce country, so the answer is water scarce country. So option C provided by Danesh. Danesh has given the correct answer. Okay. Okay, so we'll continue. Okay, so no issues with that. It is just for learning. So if you are having any doubts or anything, you can unmute yourself and talk, or you can post, but post on the chat box. But the thing is that there is nothing, no problem if you have given the wrong answer. So this will not be graded. So no issues with that. Okay. So let's continue. As I told, that international norms, a country having per capita water availability less than 1000 meter cube per year would be considered as a water scarce country. So 1000 meter cube per hour per year means 10 LLP. So this country is water scarce country. Okay. So where do we stand? Where is India in case of, in terms of LLPA, lakhs of liters per annum? Which range do we think is do you think is appropriate for India? So option A is 22 to 25 LLPA, that is surplus. This is per capita, that means per head water availability. B is, option B is 12 to 15, that is stressed. Option C is 5 to 8, that is scarce, and option D is 18 to 20, that is adequate. So what do you think about India? Where do India fall? India fall in which range in terms of per capita water availability in LLPA unit? What do you feel? Let me see. What are your answers? Okay, Jobin has told D. It is adequate. Anyone else? Actually, similar questions will be asked in your assignments or in the exam, or even being asked, I think. So these are just for learning. If you have understood the range, and you just have to remember, there is nothing conceptual. If you I mean, you can get the answer by googling also. So even if you are giving, not googling, and if you are giving the wrong answer, there is no shame in that. This is just for memorizing thing. There is no concept involved. So if you have just, you can you have to just remember the range of the water stressed, water adequate, water surplus, and water scarce countries. And if the range is, you can remember, I think you will be given a value that, see, these countries water range is, this country falls under this category, so under this range. So what type of country is this in terms of water availability? So surplus, stressed, scarce, or adequate. So there is, I mean, if certain value is asked, you can always Google it and find out the answer. So if you are not googling, then I will expect that you don't Google. Just I am just taking a feel, because when I in my institute came across the course, then I mean, I I gave the wrong answer basically. So now I know the answer. So there is no shame. So you can just go ahead and tell. Okay, so Nipu, no, Jobin has said B and Ganesh has said B. Okay, I will go forward. So what is it? Here. So what is the situation of India? So if we see the per capita water availability in India from 2001 to 15 in the cubic meter units, or if you see it in LLP unit, it will be 5, 10, 15, 20, like that way. So in 2001 it was 18 LLPA. In 2011 it it has been 15% reduced into 15 LLPA, and in 2015 it has been again 5% it has been reduced, up to 14.7 LLPA. So actually we can see the per capita water availability is getting decreased in India. Why? This problem is similar that we solved today at the beginning of the class. So basically, the population is growing. Keeping pace with that, the government is also trying to find out alternative sources for supplying the water. But the problem is that the rate of population growth is more than the rate of finding new sources of water. That is the main reason for which the per capita water availability in India is being reduced. So currently it is in the 12 to 15 range. So whoever has given the option B, it is correct. It is in the water stressed region. So we have to be aware. I mean, either in terms of population or in terms of whatever water resources are available for the people. So we are on the verge. So after stressed, it becomes scarce. So you can find in certain rural areas, people are actually uh, giving lines for I mean they are waiting in queues for a long time for filling up water. So maybe I am living in Mumbai, so I am not experiencing that kind of situations, but many news I think you have seen in the that is called in Tamil Nadu or in some south states where the water is becoming I mean, locally in those regions water are scarce. So as a whole, India is stressed, but we have to. I mean that is a thing that either in terms of population or in terms of availability of water, actually we have to reduce the uh, wastage of water, or government and big industrial sector also come out with such and such solutions to tackle the issues which are related with the India becoming a water stressed country. And it is I mean it is a very matter of concern that the in 2025 the projected uh, per capita availability of water in India is 13.4 or something, 13.4 I guess, LLP, or 1340 meter cube per year. So after that it comes on the verge of the I mean if it becomes less than 10, then actually India will become water scarce. So though it is not an individual responsibility, but collective responsibility comes from individual efforts only. So okay, so let's continue. So one good question came in the I guess Ankit has asked this question. Is Ankit there in uh, the people joining the session? Okay. So okay. So one student name as Ankit asked this question. So very good question actually. So we have seen what is water scarcity, what is water what is water surplus, what is water your that is called stress, and what is adequate. But what is economic water scarcity? Is it same as water scarcity, or it is different something? So as the course is water economics and governance, so I mean, it is very needed for us to know the concept. So what is of the concept of the what economic water scarcity is. So the formal definitions are as followed. So the first definition is given by the Food and Agricultural Organization of the United Nations. So what it is telling is that poor management of water resources where infrastructure is in place, or the lack of water infrastructure in general, this is they are calling as the economic water scarcity. So FAO of the United Nations estimates that in the areas with economic water scarcity, more than 1.6 billion people face economic water shortages throughout the world. 1.6 billion means 160 crore, I guess, right? Okay, so this many people is a pretty big number. So they face economic water shortage throughout the world because of the economic water scarcity. So what the Intergovernmental Panel on Climate Change (IPCC) is saying, they are saying economic water scarcity means infrastructure is available, but water distribution is inequitable. And another one remark by Dr. Mark Giordano, who is an water management expert at the Georgetown University. He is saying economic water scarcity has to do with the scarcity of financial and or political wherewithal. Example of such water crisis has been seen in Flint water crisis. It was observed in the United States. Uh, Failure to maintain municipal water system can also cause the economic water crisis, and also unsafe cost cutting measures may result into economic water scarcity. So what does this definition basically mean? Basically, economic water scarcity mean that there are people, there are water resources, but the proper management or proper infrastructure are not available for transferring that water from the source to the people, those who need it. So either it may be infrastructural problem. So the water availability is there. So some country may fall under the water adequate region, or may fall under the water surplus region also, but still they may be economically water scarce. How? They may, or regions of that country locally may be economically water scarce. How? So if there are infrastructural problem to transfer the available water, maybe the source may be pretty much your river water sources, that may be uh, I am not talking about sources for sewage water or something which needs extensive treatment, but the available water here means either that can be usable that can be used directly, or after a minor treatment those water can be used. So those kind of water from the source, I mean, those are available as per the demand, but people are not getting it. Why? Because it may be proper infrastructure may not be there, or even if infrastructure may be there, management issues may be there. That means some people are getting more than their required water, whereas the other people are not. So inequitable distribution, which was called in earlier definition. So the management problem may be there. So some people, or the people in those regions where they are not getting the water because of the management problem or because of the inequitable distribution, so that can create the economic water scarcity. But that is the basically thing. So one, in terms of water availability, some country may be water adequate, but in terms of water distribution, it may come under the economic water scarcity or economically water scarce country. Okay, so I believe the concept is clear. If someone has any problem, they can ask the question. It was a pretty good question asked in, or asked in the discussion forum. I thought to cater these things. Okay, so let's move on to the next problem. The question is, a lake in Bhopal having approximate volume of 5 into 10 to the power 11 meter cube with an average annual outflow of 0.7 into 10 to the power 10 meter cube per year. You have to calculate the HRT, that is hydraulic residence time for the lake to the nearest integer. So option A is 70 years, option B is 72 years, option C is 74 years, and option D 76 years. I will wait for 2 minutes for you to answer. Okay, so let's see. Wait for 1 more minute. Out there, you can open your camera also. Is Jobini has given the answer as B. Okay, I'll wait for 1 more minute. Okay, Nipu has also given option B. Okay, okay, so it is pretty simple problem. I think I'll go with the solutions. So basically, what hydraulic residence time is, if you simply consider a tank and a flow is coming inside the tank, flow is going out. If the flow in equals to the flow out, that means the tank is in steady state. The water level in the tank is not increasing or decreasing. Then the hydraulic residence time, or HRT, comes out to be the volume of the tank divided by the flow out, because flow in or flow out equal. So here in this case, residence time is the average duration of a particle of water to pass through a phase of hydrological cycle. Now, to so if we consider one water particle to represent the most of the water particles which are coming inside or going out, so that the thing, the tank must, the water inside the tank, water flow inside the tank must be in the steady state. So here we can consider the tank to be uh, mm, watershed or lake, as in our question. So there we have to simply divide the uh, volume of the lake, that is 5 into 10 to the power 11 meter cube, that is here tank volume, there it is lake volume, divided by the flow out, that is 0.7 into 10 to the power 10 meter cube per hour as given in the question. It comes out to be 71.43, and both of you have given the correct answer as B, 72 years. So the thing is that here hydraulic residence time is a pretty simple concept, but when the tank becomes a reactor or small water body or something, when the water is not in steady state, there many things may occur. So as I am from chemical engineering background, in our case, uh, unsteady state situations also comes into the picture. So there, uh, in case of HRT, and another concept comes into the picture, that is called residence time distribution, RTD. Just for your knowledge, it is not required in water course. So the RTD, how it is done? Either it is calculated with the help of pulse test or step test, etc. So either water is going, for example, liquid in white color is going. So one red particle, drop of red particles is injected at the inlet. So and at the outlet the response is noted. So the after how much time one is getting the uh, red particles at the outlet, depending on actually Gaussian distribution comes. So those are actually called residence time distribution. So those are very complex concept when the unsteady states and other reactor design and everything comes into the picture. Also when uh, the companies have to design the water treatment plant for effluent treatment purpose for industries, or so many other concepts such as solid retention time or SRT or sludge retention time. Those things come into the picture in case of activated such process, but here it is pretty simple. It is basically HRT. So you don't have to worry about that. Just for your knowledge, I told. Okay. Now let's move on to the next problem, next MCQ. This is, which amongst the following is India's largest river system in the Deccan region? So option A is Ganga, option B is Narmada, option C is Brahmaputra, option D is Godavari. So I'll wait for again 1 minute for you to answer. Okay, Nipu is telling option A, Ganga, the largest river. Okay, I'll wait for 1 minute. You can Google it, but I'll discourage that, because you can always Google it and get the answers. That is not the point. Okay. Jobin is telling option D, Godavari. Okay, so I'll go with the answers. So I believe Jobin has given the correct answer of this. Okay. So option D is Godavari, because it is told that it is in the Deccan region. Ganga is definitely the largest river of India, having 2,525 kilometers, but they have specifically mentioned it to be the Deccan region, so that's why it is Godavari. And Godavari is the second largest and the largest of the Deccan region. It has got length of 1465 kilometers, and Narmada is the least long of them. It has got a length of I guess 1300 or something. Yeah, 1300 or something kilometers Narmada have got the length. And here is an interesting fact. Brahmaputra is the largest river among all the four. But why Brahmaputra has got a length of 2900 kilometer, but the Brahmaputra is not a single country river. Here it is mentioned as India's largest river system. So people who know the length of Brahmaputra, they will say that it is the largest river system if the Deccan region is not mentioned. But the part of Brahmaputra which is there in India, that is that has been flowed through the northeast region. So that has got length which is lesser than the Ganga and Godavari. But the total length of Brahmaputra, probably it has started in the Tibet. So within the Tibet, the northeast states, and certain parts are there in Bangladesh also before it gets mixed with the Padma River. So the total length of Brahmaputra is 29900. So it is the largest, even larger than Ganga. But the region portion of Brahmaputra that is in India, that is lesser than Godavari. That is lesser than Ganga and Godavari. Okay. So lesser than Narmada is there or not? I don't remember. I have to check. But yes. So the thing is that it is a case. So total length is small. 29900 kilometers is the total length of Brahmaputra. Maybe the Brahmaputra name is not also there. In China, it has, in Tibet, it has been flown in the name of Shangpo, I guess. Okay. Okay, so Godavari is the correct answer. Let's move on. So now we'll solve a problem together. Oh, let me see the time. So sometimes if I exceed it, okay, so it is 10 minutes are still there, so we can solve. No issues with that. Okay. Yes, yes. Jopin is saying has tributaries, yes. So the thing is that sometimes some rivers are branched rivers, so it comes out of the other rivers. Some are sub rivers. That means those rivers join other rivers. So based on that, actually, in the watershed or water balance equation, the outflow, inflow, or infiltration, outfiltration, those things are considered actually. Delta S is in that equation is the change in storage, and the other uh, term that is there is the precipitation, and runoff is basically the water flow. So I believe this problem also you have to utilize there. Okay, let's see. So at a given instant, the storage of water in the reach was estimated as 18 into 10 to the power 4 meter cube. What would be the storage in the reach after an interval of 3 hours if the average inflow and outflow during the time period are 14.4 and 10.9 meter cube per second respectively? The options are option A, 21680 meter cube, option B, 21780 meter cube, option C is 21770 meter cube, and option D is 21670 meter cube. So hint, as I told earlier, that you have to use the water balance equation to solve the problem. I'll wait for 2 minutes for you to solve the problem. So I think this is the last problem. Okay, for a few more time. No. This is not the last problem. Still other problems are there. Okay, so yes, I'll wait for 2 minutes for you. No problem. Danesh has given the answer, I guess. Option B, 21780. I don't remember the answer. We will see you after the solver. This answer I forgot. Okay. Very simple problem. You can use the water balance equation and you can come out. And you have to look that what terminologies in water balance equation is coming out to be zero, which are not going to be zero. You have to look for that, and you have to keep in mind the unit. Only these two simple things you have to run, and the rest is simple arithmetic, nothing else. But I guess in the first assignment, still people had doubt in this kind of problems. I went through more basic problems, but people was not able to solve these problems, so they asked to so that I should discuss solution of these problems, this kind of problems in later section. So these are similar problems, not the exactly same, but if you have understood and solved it yourself, then assignment problems will take not more than 1 hour to solve one assignment. If you know all the short question answers, that is MCQ answers, those are just conceptual questions or memory type of questions. So those you have to remember. And the other these numerical problems, one numerical problems will take 7 or 10 minutes maximum 15 minutes. The exam of you which will occur at the October 17, I guess. Oh no, after October 17. So October 17 is our last class. October, maybe 28th October or so. So I don't think passing will be a problem in those problems. If you are attending the lectures, and even if you are not attending live sessions, if you are seeing the recorded lectures, that will be fine. But I encourage you to attend the live sessions, everyone. So then if you are attending both, then you don't have to even practice yourself. The session itself, it will be practiced, and it will be very easier for you. So it will not create much problem. Okay. Okay. Tornesh has asked one question. Sir, wrong answer submitted in assignment has negative marks. I don't think in the assignment negative marks are there, but okay, I'll clarify this. Okay, I'll note down this question. I'll clarify this for you in the upcoming session. I'll ask the NPTEL team. I don't think in assignment there will be. I mean, you can submit the assignment number of times, and in the final exam maybe negative marks there, but I don't think assignment negative marks are there. But okay, well, I'll clarify this in the next session. Whether negative marks are there in the assignment. I don't think so. Is there? But still, it is better. You can. I mean, next session is on 17, I guess, right? No, 15. So before that, within 9, within tomorrow, you have to have submit 1 or 2 assignments, right? So I suggest you to ask direct this question to what is called NPTEL support team. So they are there. You can direct this question to them directly. So the email ID, I have to check. Just wait. I'm giving you the email ID. Please support. Yeah, I got it. So here you can directly email them. They will directly answer your query. I guess it is their email ID only. Okay. You can also ask this question in the discussion forum if you don't get a reply from this email ID. Okay, so we will go with the solution of this problem. Okay, so Jobin has given C. Okay, there it is. Oh, no. No, there. So here again you have to use the water balance equation and keep in mind which terms are becoming zero here. So I think the data given in the problem are the incoming flow rate, that is 14.4 meter cube per second, and the outflow rate is 10.9 meter cube per second. The initial storage is 18 into 10 to the power 4 meter cube. The inflow volume in 3 hours. That is, within 3 hours, how much of total water is coming inside. That is meter per second, meter cube per second. So 3600 seconds per hour into 3 hours into 14.4 meter cube per second comes out to be this amount is coming inside within 3 hours. And similarly, outflow volume in 3 hours is this 10.9, the outflow rate into 3 hours into 3600 seconds per hour. This is this much amount of meter cube. So from water balance equation, inflow minus outflow equals to change of storage, that is the delta S. So no precipitation is there, P term is 0, and no evapotranspiration is there, ET term is 0. Only Q in minus Q out equals to delta S. This you have to use. So how can you use the how can you express the change in storage term? It is nothing but final storage minus initial storage. So inflow term is this and outflow term is this. Just two are put here, equals to final storage minus initial storage that was given in the problem. So it is 18 into the power 4 meter cube, and in this way the final answer comes out to be this terminology, that is 37800 meter, and this goes to the left hand side and becomes plus. So this is the answer. Okay. Option B is the correct. Yeah. Now, okay, I don't think any more problem is there. So we have come to the end of the session. If you have got any doubt, you can ask either in the your chat box, or you can unmute yourself and speak up. Whatever we have discussed today, or if you wish me to, if you're having any doubt in assignments, then please tell me the assignment number and problem. I'll solve similar problem. Or if you have got any problem with your conceptual understanding, then you can tell. I will clarify that thing in the next session. Otherwise, I will continue with regular problem solving. Those are similar to the assignments. Mostly MCQs are there. So I'll go through the MCQs, and I'll also try to put some new concepts. So these sessions are not only for solving assignment problems. So if you I mean, just for learning also, for interaction also, and if you have got something of your own to share, you can also always speak up. It's an interactive session, both way interactions, and I am also just a student like you. So, okay, see you guys next week.
Okay, sir.
We'll have
Thank you, sir.
Mhm. Stop the recording. The session. And this session will be uploaded in YouTube, the recordings.